Hi there, today we're diving into a cool little gadget, the IR Infrared Obstacle Avoidance Sensor. Whether you're building a robot or smart car, this sensor helps your project see nearby objects without touching them. This sensor uses infrared light to detect obstacles. It has two main parts: an IR transmitter that sends out invisible light and an IR receiver that sees if the light bounces back from something. Think of it like shining a flashlight in the dark. If the light hits a wall and bounces back, you know there's something there. How it works: if there's an object in front, the IR light reflects back to the receiver. The sensor then sends a low signal, 0 volt, to tell your Arduino, hey, there's something here. If no object is detected, it sends a high signal, 5 volt. We also have two potentiometers. We can adjust them from these holes. The first blue potentiometer is distance sensitivity. It's for distance sensitivity, often marked as S or DIST. The purpose to adjust how close or far an object must be to trigger detection. Turn this to control how far away the sensor can see an object. The second blue potentiometer is for output threshold or environmental brightness, sometimes marked as E or ENV. The purpose to adjust how strong the reflected light must be to trigger a response. Useful in tuning for different lighting environment like sunny rooms or dark spaces. Wiring the sensor to Arduino Mega. We have 4 pins. Some sensors, obstacle avoidance sensors, has 3 pins. Some of them have 4 pins. As you see here, there is ground here, so the second will be the output, the third will be the VCC. The fourth pin is EN. It's for enable or disable the sensor. We will not consider this pin in our project, but it's useful when you need to disable this sensor in your code, whatever, after he worked or not. It's useful, but we will not use this disable pin. What we need Arduino Mega, we need obstacle avoidance sensor, we need LED, we need a resistor, 220 ohm. We need to light this LED when the sensor detects an object, and turn it off if there's no detected object. Let's see our code. As you see, first of all, we define the pin connected to the IR sensor, and we define the pin connected to the LED. In void setup, we set the sensor pin as input using pin mode, and we set the LED pin as an output using pin mode also. We start the serial monitor at 2600 bits per second This allows us to see messages from an Arduino to the computer. Void loop, we read a signal coming from the sensor using digital write and put the output of what we read in the obstacle. And if the obstacle is low, that the sensor detects an object, we will light the LED using digital write. We send high signal. And we write and serial monitor that obstacle detected, else there is no object detected. We send low to the LED bin using digital write, then write on the serial monitor, no obstacle, then wait for 200 milliseconds. Let's go to our circuit and